Okay, last time we started the topic of earthworks for roads, and before that we did a small example with the building projects when earthwork is considered as external work for the buildings. Okay, so we discussed why it is important, okay, what are we trying to find out, and what type of drawings we need to do this, what type of cross sections we have. If you have cross sections, how you can combine them to calculate the volume. And when you're calculating the volume, you need to consider the shrinkage as well because of compaction. Then I showed you this example. You have the full table available in the slides. Okay, I just showed you a couple of samples of how to calculate the volume using these areas. And the area calculation you already covered in surveying, okay, or other courses as well. You mentioned numerical and so on. Okay. Now the last column which we calculated is called the mass haul ordinate. Okay, and this is one of the things in which road projects are different, because in building projects you are only interested in quantities. In road projects you are also interested in distances. Okay, so we need a diagram which shows us the quantity with respect to distance, and you can see the same thing in the table as well. So you have the distances as stations, and you have the net cumulative quantity of earthwork. Okay, so we are saying net cumulative. Okay, net means what? Why are we calling it net quantity? Net of what? Final of what? Net means a difference. So I am taking a difference. Difference of what? Positive and negative. What is positive? Cut is positive. Okay, so net means at every station you will take the net. Okay, cut minus fill. And cumulative means add that. Okay. Now if you see these numbers which are in negative, the negative numbers show what? It's fill. It's fill, or because now you look at the first, this is from where we started, right? So do you only see fill here? No. So there is cut, right? So the negative means what? Fill is more. There is cut. You cannot say it's fill. There is cut as well. Okay, there is cut as well. So you cannot say it's fill. Okay, because there is so much of cut here. Okay, it's not even negligible. You cannot even just say, okay, I will round it off to 0. It's too much. Okay, but the fill is more than the cut. Okay, so the net quantity does not tell you how much you need exactly. It tells you the overall picture. Okay, after net and after adding, it tells you the overall picture. Okay, in this case we are calculating in cubic yards because the example is in feet, and if you are doing it in meters, then simple cubic meters. Okay, it becomes much easier. Okay, and the first station is taken as 0. Okay, and why it is taken as 0? Because we are interested in area. Okay, so at one station you can we are interested in volume. We are interested in volume. So first station means first point. You cannot have volume for a point. You need two areas, right, to take the length. Okay, so that's why the first one is 0 in all cases. Okay. So this is the plot which we have made from this table. The first column on the x-axis, the last column on the y-axis. Okay, this is called as a mass haul diagram. Okay, it is called as a mass haul diagram. This diagram tells you the total quantity required with respect to distance. Okay, total net quantity required with respect to distance. And as I mentioned that you have a 0 line, and the quantity can go more than 0 or even less than 0 because fill is taken as negative. So when the line goes less than 0, that means fill is more. When the line goes above 0, that means cut is more. Okay, but it does not mean that's only fill or only cut. Okay, this is the net. Okay, what else? The first point I already mentioned. Yeah, the slope. Okay, so if the slope is going up in the diagram, what is happening? Slope going up means positive is increasing, right? Okay, so that means what is happening? The cut areas, you are having cut areas now. Okay, or the areas which are having more cut quantities. That is what is causing the slope to go up. Okay, and the downward slope means vice versa, the other way around. Okay, when you see the slope going downward, that means fill quantities are increasing. So either you are having fill areas or areas which are having more fill quantities. Okay. Yeah. The minimum point is here. The maximum point is there, f dash. Okay. F dash, yes. The minimum point is this one, and the maximum point is that one. So minimum point means this is the end of negative was fill, right? So this is the end of filling. Okay, after that the cut quantities have started to increase. Okay, because when the fill was increasing, we were going down. Okay, so the negative point shows the end of more cut quantities, end of more fill quantities. After that it will go in the other direction. Okay, and same thing for the maximum point. The maximum shows that this is the end of having more cut quantities. After that the slope will start to go down, right? Okay, so they are basically showing you the change in the trend of the diagram. Yeah. Okay, if I want, for example, this is giving me the quantities from the start till the end. Let's say I'm only interested in this part of the road between station 4 and 8. Okay, I'm only interested in this part of the road which is between station 4 and 8. Okay, so I'll take the ordinate at station 4, I'll take the ordinate at station 8, and I will take the difference. Okay, and this will give me the quantity between these two stations. Okay, so whenever you want the quantity between any particular part of the road, at any particular part of the road, you will take the ordinates from here and you take the difference. It will give you the quantity for that part of the road. Okay, otherwise if you just read the number, the point is, if I just read the number, so for example I need quantity between 4 and 8, and I take the number for station 8. Okay, this is from 0 till 8. Okay, so you cannot take it for this part of the road. What else? Yeah, so whenever you see the 0 axis in the mass haul diagram, that is called as a balance line. The 0 axis, okay, or the axis which is intersecting the 0 on the y is called the balance line. Okay, balance of what? Balance of cut and fill. Okay, because the line will cross 0 when cut becomes what? No, the line will only cross 0 when cut equals fill. Okay, so cut equals fill means total balance. I excavated 100 cubic yard and I filled 100 cubic yard. Okay, so 100 minus 100 plus 0. Okay, so that's why we call it the balance line. And you can see the balance lines here, A and D dash to E dash. So these are the balance line. At these points the cut becomes equal to fill. Yeah, so I start from A dash, I reach D dash, my cut becomes equal to fill, right? Balanced. If I end the project here, I don't have any extra material. I don't have to buy any material. I don't have any extra material on the site to dispose. Okay. But my project continues, right? It's going beyond D dash as well. So it goes beyond D dash till E dash. Okay. When I reach E dash, what happens again? My cut becomes equal to fill. So again, no extra quantity. Okay. Nothing on the site to dispose and nothing I have to buy. Okay. But that road project does not end here. It goes beyond E dash as well. It is ending here at station 20. Okay. So the line is in the negative, right? The line is going down. That means what? What will I have? More material on the side, or I have to buy more material? I have to buy more material. Okay. So at the end of the project, I need this much quantity of extra material. Clear? Okay. I need this much quantity of extra material on the site to fill the last part of the road. Okay. Before that, they are balancing. Clear? So this will give you the total quantity of material which you will need at the end. Okay. If I just take this value, which is almost 500, so I need 500 cubic yards of material on the site at the end. Okay. But I don't need it everywhere, right? I need it at the end. Okay. So that's why the mass flow diagram is important. Yeah. 0 is what we call as the natural balance line. 0 is the natural balance, right? Cut becomes equal to fill. Okay. But they are, if you draw line between any two ordinates which are at the same level. If I draw the line between any 2 points which are at the same level. Okay. So if I draw a line here, well, you can see this line JK. Okay. Now what was happening here? It was more cut, more fill, right? And here it is what? More cut. Okay. But the quantities are same. Okay. So this can also become a balance line. Okay. This will also become a balance line. But balance line not for the project. It is only balance line between these 2 points. So whatever I get up to this point, I can fill it up to this point. Okay, this is the idea. These balance lines which are not zero, the non-zero balance lines, whatever you get from one end, by the time you reach the other end, all of this material is consumed. All of this material is filled. Got it? Clear? So these are other balance lines as well, and this is what the contractors use in the end. I will come back to it with an example. Okay. When we are making the road projects, I told you earthwork is the main cost item. Okay, or the only cost item, because I'm talking about road projects like which are on the ground, not bridge. Obviously, bridge you have the whole structure. You have to consider the cost of the foundation and the excavation and the pillar and everything. Okay, I'm talking about the normal highway projects which are on the ground. So the projects which are on the ground, the cost of earthworks is the most important item. Okay, the other things, curbs and barriers, they are very few. Okay, they take very little of the cost. So I have to minimize the cost of the earthwork. Okay, I try to minimize the cost of the earthwork. Okay, now tell me how the cost of earthwork will become less if I have a balance. Okay, because if I have more fill, I have to buy material, cost. If I have more cut, I have to dispose the material, right? Cost. If I can balance between them, no material coming to the site, no material going out of the site. So that cost is gone. Okay. So I need what? I need cut and fill both, right? I need some cut areas and I need some fill areas. If I have only one type of them, I will never balance. Okay. If I am only doing cut and cut, I will never balance. I am only doing fill and fill, I will never balance. Okay. So I need to balance between them. Let's say you selected a location, or the location was given to you and they said, okay, you have to design your road on this location, or you decided I will design the road on this location. This is my route. Okay, I will go from point A to B to C and so on and so forth. Okay, and you calculated the earthwork. You calculated the earthwork and you found that it is not balanced. I selected a gradient, I found the elevation of the terrain, and on the basis of that, I calculated the earthwork. And in the end, I found that I have a problem. The quantities are not balanced. Okay, and you can have two cases. You did more cut and less fill. So now you have excess material on the site. You have extra material on the site. Okay. Now the option is, okay, I have this extra material, I'll bring the truck and I will get it disposed of somewhere else. Okay, and it will take cost and you may have to take permission as well. Because you cannot just throw material anywhere, right? Okay, there are areas where you will throw it and so on. Or you can do one of these things. Okay, so embankment means what? Embankment means this is called as an embankment, the side slope. Okay, so you see the ground level is high, the road level is low. Okay, so I will do the cutting like this. So make sure that it is stable. This is called embankment. Okay, this is called as embankment. Okay, now tell me which slope is more stable, the one which is steep or the one which is flat? Which one is more stable? Flat one is more stable, right? But flat one needs more height and more length. To make it flat, I need extra material fill here, right? Yeah. Okay. So if you have this case where you dig the earthwork and you found later on that I have some extra material remaining on my site, I can throw it off or I can put it in these embankments. Okay, I can make my embankments longer and higher, okay, to make them more stable. Okay, so if you have extra material, instead of throwing it off, you can put them in the embankments. Okay, so it will make the embankment more stable. It will make your structure more it will make it more stronger. Clear? Okay, so you can use it in the project, same project. Okay, they are saying the same thing. More width, more height means less slope, right? So 3 points are the same. What if you need, you did the earthwork and you found that I have more filling, less cutting. So I don't have a balance, but the balance is now reverse. In the first case, the balance, I had a non-balance positive. There's no balance, but it was positive. I have extra material. In the second case, again not balance, but I need extra material now. Okay, I need extra material. Okay, clear or not? So what can we do? We will do the same thing which we did in the first case. Okay, so instead of buying the material from somewhere, I'll go to my site and whatever slope I have, okay, I'll try to cut it more. Okay, again to make the slope flatter. Okay, if I cut it like this, okay, so slope will be steeper. I will have less material. But if I make it like this, I'll cut it more, right? So I will have extra material now. Clear? Okay. So the point is, in both cases, if you need extra material, you can do more cutting from areas where you need it to make the slope flat. And this extra material will be used in filling wherever you need it. Okay. And if you have extra material, again, you put it in the slope, make it flat and wide and so on. Okay. So whatever adjustments you need in your earthwork, you can do it in the side slope. I have extra material, put it in the side slope. I need extra material, take it from the side slope. Okay, but in both cases, we are making the side slope what? Flatter. Because flatter side slope will give you more strength, better stability. Clear? Okay. Whether you have extra material, whether you don't have extra material, whether you are whether the project is balanced or not balanced on paper. You cannot do filling without looking at the properties of the soil you are filling. Okay, so I took the soil from here and I'm going to fill it somewhere else. This was natural soil. It can be anything. It can be rocks, it can be sand, it can be clay, okay, it can be what they call a silt, okay, it can be the sand which you find near the beach, okay. So all types of sand is not usable. All types of sand is not usable, okay. So you have to test the soil before you start filling. If the soil is not usable, it is weak, it has high water content, it is very fine, then you will dispose it. You have to dispose it. Okay? Clear? You will not put it in the side slope or anything. It will make it weaker. Okay? So before you start filling with any type of material, whether from the side or you buy it, you have to check its strength and its suitability for the project. If it is not suitable, you have to dispose it. If this material is from the side, so I cut it from here, it is, let's say, 20 cubic yard. Okay, but I cannot use it because it's very weak, it's very fine. Okay, so I will subtract this cubic yard, 20 cubic yard from the filling, because I cannot use this in filling, right? So this 20 cubic yard, I have to bring it from somewhere else. So let's say the filling was 80 cubic yard. The filling was 80 cubic yard. The cut was something, whatever. But from that X, from that cut, the 20 cubic yard is not usable. Okay? So if I could use this 20 cubic yard, then I can fill 80 cubic yard with this material, right? Okay? So this 20 cubic yard is now have to be disposed. So whatever material I have available on site, I need 20 cubic yard more to do the fill. Got it? Okay? So you have to subtract the unusable material from the fill, because you cannot use it for fill now. Okay? So it will not go in the balance. This 20 cubic yard will remain extra in the balance. Okay. So let's say we have we have to find out the balance points. Let's say in the diagram we have. Okay. Before that, we made this diagram from this table. Okay. Very good. I like these people. Everything is okay. You don't know what to do. Okay. Okay. So now tell me from the diagram, where is the balance point? Well, from the table, sorry.
The first one?
The first one is the very good. Yes, yes. Okay, yes. The first one is the balance point. Okay, where else? What should I do with this? The first one is balance. Okay. Because we didn't start, right? A man came and said, I never got an F in my entire life. He said, I never went to school. You don't go to school, you never get an F, right? Yes. It's the same thing. You didn't even start the project, you are at point 0. So obviously you are balanced. Yes, tell me. Station 14 and 20. Direct? You went from 14 to direct 20? Yes. 9 and 10. Because at 9 it was negative, at 10 it became positive, right? Okay. So wherever the balance point is between these two. Okay. Balance point is which point? Where we reach what? 0. Okay. So the 0 is somewhere between them, right? Okay. So yes, the first balance point is station 0. There is no doubt about it. Okay. But the other balance point is where you switch from minus to plus. Okay. But the problem is it is between these two. But where exactly? Okay. So with the balance point, you cannot just round it off to the nearest station. You cannot say, okay, 9 or 10. And in this case, you are not even close, right? If you take 9, you are 299 cubic yards off negative. If you take it 10, then 200 cubic yards off positive. Okay, if it was 200 or sorry 0 point something something, okay, I will say okay, round it off. Okay, but it's very 200 cubic yards, there's a lot of amount. Okay, so we need to find out the exact point where it will be the balance point. Okay, so what should I do? I will do the interpolation. Okay, or you guys will do the interpolation? No?
There is
Yeah.
another way.
There is?
Another way.
Yes, there is another. Then,
Take the escape from the graph.
okay.
Keep it.
Bring the escape. I will show you the graph. Yes, that is another way. Yes. Yes. If you made this diagram yourself and you have proper graph paper with grid lines, you can do it. Still, there is a chance that you may have a point which is between the two grid lines, but the difference will be very minor. Yes, we can do it. Yes. Okay, but in this case, or for the sake of the exam, you will do the interpolation, right? Okay. So if I do the interpolation, what point I will get? I get 9 plus 6, 0. Okay. For people who are thinking what scientific discovery we are talking about, what is interpolation? So I just show you the equation for once. Okay. But you will do it multiple times. If you have a question like this, you may have to do interpolation multiple times. So if I go back to the table, okay, so at 9 I have minus 299, at 10 I have 20, what? 1. Okay, the equation for, and I need it when at 0, right? I need it x at 0. So this is my x1, this is my x2, this is my y1, this is my y2, and this is my y. Okay, so interpolation works like this. Okay, or if you say y minus y1 minus y2, no problem, just do x1 minus. Whatever you're doing here should be there as well. Okay, that's the whole point. Okay, so my x I don't know. X1 is 9, x2 is 10. Okay, so now keep in mind 9 and 10 is the station. 9 and 10 is the station. Okay, and y is 0, y1 is minus 299. You can put it with the sign because I'm looking for 0. You have to put it with the sign, otherwise you will never get 0. Okay, this goes with the sign, no absolute here. Okay, so y1 is minus, so minus and minus plus, got it? Okay, 201, again minus and minus plus. Okay, now this will give you answer what? You can calculate, no problem. Okay, but the answer which you are looking for in the graph, it says 9 plus 60, right? 9 plus 60. So this will give you what? 9 plus 60? It cannot give you 9 plus 60. Right? It will give you what? If I put these values here, I'll get x1 equals to what? They are saying x1 is 9 plus 60 stations. But this equation cannot give me any equation. No equation can give you a value 9 plus 60. Right? So this equation will give me what? 9 and 60? Could be, makes sense, because each station is 100, right? But I did something when I wrote the value, so it will not give me 960. To get 960, I should put x1 and x2 differently. Are you getting the point?
96.
96?
I don't understand.
96 stations means
Because it
9,000.
as nine, you didn't take it as 900.
I didn't take it 900. Yes,
Yeah.
my mistake. And your mistake, you are in my class. Yes. If I put, so everybody agrees, if I put 900 and 1000, I'll get 960, right? Make sense? Clear? Okay. So to get 960, I should put x1 as 900 and x2 as 1000. This much is obvious, right? Okay. Now going back to the question, I did not put it as 900 and 1000. So what will I get in this case? I'll get a value of x 9.6. Okay, just miss the point, right? Now sometimes it can happen to me. I just miss the point. Like I have to give you 10, and I give you 1. It's just a point, right? Who cares? Okay. So got it? So 9.6 means 9.6 station means 960. We'll multiply 100 because this station is 100. So just you just need to keep it in mind. If everybody puts 9 as 900 and 10 as 1000, no problem. If you put 9 and 10 and you solve it, no problem. But in the end, you should know what you are doing. Okay, you put 9 and 10, you get 9.6, and then you tell me no, it was 9.6 feet. Then it's a problem. Okay, you just need to keep in mind, are you putting stations or distance? If you are putting distance, you get the answer in distance. If you are putting stations, you get the answer in stations. Clear? Clear? Okay. So the first balance point is this one. Okay. The second one is this one, and the third one is E dash. Now E dash is between what? For E dash again I have to do interpolation, right? I told you you have to do interpolation multiple times. Okay, so E dash is between what?
-1.
So stations. Which is stations? 17 and 18, right? 17 and 18. We have to do interpolation between them. Clear? Clear? Okay. This is like the natural balance point where the line goes to 0. So there is no issue with that. And I told you there can be other balance points or other balance lines. Okay, where the quantities become at the same level. Okay. Any distance at which you get quantities at the same level, this becomes a balance line because this one is going up and this one is going down. So this one means this much cut and this one means this much fill. Okay, so the quantities become balanced. Okay, so those lines, then you need to go and check the graph. Those balance lines, 0, you can, I give you table, 0 balance point, no problem. Anybody can see where it's going positive, negative, and you can find out the 0 balance. Okay, but this one where you are making your own balance line. Okay, so for this one I need the graph. For this one I need the graph. So I cannot come and say, okay, I will make balance between 4 and 8. Okay, so between 4 and 8 I go here. Okay, so what's my value? I don't know. Okay, and then 8. Where is it? Okay, now you see the problem. At 4, I went to the diagram. When I went to the 8, am I at the same level? No, 8 is somewhere here. Okay, is it making sense? Okay, if I make a balance line from 4 to 8, I will go out of the graph, right? So it's no longer balanced. It's no longer balanced. Got it? So for other balance lines, you need the graph. Okay, you cannot just look at the table. Okay, from 4 to 8, I will do interpolation between them. No, it will not work. Those points have to be on the same level on the graph. Clear? So I can make a balance line between B dash and C dash, right? Because they are at the same level. But what station is this? I need the graph. Got it? Okay, so for other balance lines, we need the graph. Here in the question, they are saying, because they made the graph, so they are saying there is a balance line at 500 as well. At 500 or 5 stations as well, which is between J and K. Okay, so there is a portion of 5 stations at which the graph at both ends are at the same level. the curve at both ends are at the same level. So between J and K, the distance is 5 stations and the ordinates are at the same level. Okay, so this can be a balanced line. Can I make it 600? Can I make a balanced line 600? Okay, I may, but I have to look at the ordinates myself. Where is it? Okay, like I don't know where is J and K. I don't know where is J and K until they tell me this is where they are meeting. Okay, so going back to the point, you cannot make extra balanced lines until you have the graph yourself. Okay. So if you have yes, if I am cutting, so my road project had 20 stations, right? 20 stations in feet means 2000 feet, which is not a lot. It's like less than half a mile. Okay, half a mile means around 800 meters. Okay, well, less than 1 kilometer. Less than 1 kilometer. So it could be less of a problem. Okay, but some road projects are very long. Okay, some road projects are very long. I gave the example last time of the causeway, right? It's more than 20 kilometers long. Okay, so now you tell the contractor, okay, my project is balanced. Take material from here. My fill quantity is equal to cut quantity. Everything is balanced. Okay, so I will not give you any extra payment for filling or cutting. Or I will not give you any extra payment for material, because you are taking the material from one point and putting it on the other point. Okay, makes sense? Makes sense, right? I don't need any extra material. Why should I pay to him? Okay, but what is important here? The quantity and the distance. Okay, now you are asking him, okay, take the material from there, put in the truck, go 10 kilometers forward, and you are making the road, so there is no road. So he may not go 10 kilometers like this. He may go to the road and then come 10 kilometers. Okay, so in that case, the contractor will say, okay, no, you are making me move so much material to so much distance. Okay, so you have to pay me extra for transporting the material, even if it is balanced. Okay, so that cost is called as overhaul payment. Okay, hauling means transferring something. Hauling is transferring something. Haul, transfer. Okay, so here he is transferring the material from cut site to fill site. Okay, so usually it's not like, okay, you have to cut material from here, bring it 2 meters forward and fill it. He cannot ask you for payment like this. So you agree on a distance. If the balance is between these two points, or between this or within this distance, I will not give you any payment for transferring the material. Okay, if it is more than that, if you have to transfer the material from cut to fill to more distance than this value, I will pay you extra, and that extra payment is called as overhaul payment. Got it? So hauling is transferring the material. You agree to the contractor up to which distance he will transfer the material from cut to fill without any extra payment. Anything more than that will go in overhaul payment. Clear? So it is part of the contract which you have with the contractor. Okay. Yeah. The payment is done per unit station per cubic yard material. Okay, so it will, if it's taking 1 cubic yard material, but he is transferring it to 10 stations, so the cost will be multiplied by 10. Okay, he is transferring 10 cubic yard to 10 station, again it will be multiplied by 10. Okay, so it will increase if the material quantity is increasing or if the distance is increasing. In both cases it will increase. Okay, if you have a small quantity of material but more distance, you have to pay more. If you have more quantity of material, less distance, still you have to pay him more. Okay, because for more quantity he will maybe take a bigger truck or something, right? So that's why. Yeah, the distance for which he is not charging is called free haul. Okay, so the distance in which he agrees, I will not ask for any payment, that is free haul. After that, we have overhaul. Okay. So let's say for this diagram, the project which we are looking at, in this diagram or in this project, the contractor agreed to not have any payment for 500 feet of transfer. Up to 5 stations, he will transfer the material from cut to fill without any extra payment. Okay. So what do we call this 500 feet? What distance? Free haul distance. Okay. Anything more than that, I will charge you extra. Okay. So if I go to the diagram, I have to find points which are 500 feet from each other, okay, which are at 500 feet from each other, and between these 2 points he can transfer the material completely, balance. Okay, so I need to find out 2 points, or the points which have a distance, which have equal quantities, and the distance between them is 500. Okay, so between these 2 points he will consume his free haul. Okay, between the 2 points, balance points of 500 feet, he will consume his free haul. For example, what will happen? This J and K have a distance of 500 feet. The distance between them is free haul. Okay, so what he will do now? What is more at J? Cut or fill? Fill, right? It's going down. What is more here? Cut. Okay, so what he will do? He will cut it from here or up to here. Whatever he's cutting, he can fill it up to here. Okay, so between these 2 points, the cut and fill will become balanced. Okay, same thing for S and T. Okay, whatever he is cutting from S till he reaches T, he will fill it, all of it. Clear? Anything more? Then he will ask for the overhaul payment. Clear? Okay, and how do I get these points? J, K, S and T. I have to do what?
500 minus.
Yes, interpolation, right?
From the graph.
From the graph, Yani, yes. Okay, not Yani, Achi. Whatever you ask for. Okay, no other way. I told you, this is what I have been saying. Okay, this is not zero balance. You can find out zero balance from interpolation. Okay, I cannot just interpolate between these 2 points and say they are exactly same and they have 500 feet between them. I cannot say this. Even for J and K, if I tell you exactly where is J and K and you calculate the quantities, we will see later on there is a difference between them. In the graph, they are showing same level, right? J and K is same level. Okay, but actually, when you try to calculate the ordinate at J and K, you will see the difference. So they are not actually, by calculation it will never give you the same value. Okay, why? Because there is a curve. How did I make the curve? Okay, so for example, if J is between station 7 and 8, so I have a value at station 7, right? I have other value at station 8. I joined them, right? Okay, you may join them like this, I may join them artistically like this. Okay, or this is how I make my handwriting. So, I'm very good at curves. I cannot draw a straight line. So one of you may draw a straight line, completely straight. Okay, another one is going, like he will go to Muharrak and come back. Right? The line will be like this. So between the 2 points, it's all how you are drawing it. Okay, so you may get different answers. So that's why you need the graph, and if you try to calculate it, you will not get the same answer. Okay, what was the question? Okay, we will not do the overhaul calculations now, but just to explain you, you have to come to the graph. You will put a scale or something here, and you will see where is the distance of 500 feet, where the 2 ends are at the same level. Okay, so you have to, for example, I put a value here, and I see, can I go to the other end of the graph at 500 feet? Okay, so if I'm at this point and I try to go 500 feet forward, I'll not reach the other end of the graph, right? So this level is not okay. So I have to go down. Okay, so this is how you do trial and error on the graph. Okay, so first of all, I found a point J. When I go 500 feet forward from here, I'm at the other end of the graph. Okay, so this can be a balanced line or a freehold distance for my contractor. Okay, so how do I get the value? I have to read it from the graph. Okay, same thing for S and T. You will go on the upper part of the graph and you will see from which point I can go 500 feet forward and reach the other end. Okay, so if you are below S, you try to go 500 feet forward, you will not reach the other end, you will be short. Okay, if you go above S and go 500 feet forward, you will go out of the graph. Same thing will happen here, right? If I am at B dash, I go 500 feet forward, I will be out of the graph. Okay, if I am here above J, I go 500 feet forward, I will be somewhere here. Okay, so you have to go to the graph and you will mark your point, go 500 feet forward. If you reach the other point of the graph, this is your balance. Clear? Okay, but this happens on each side of the zero. Okay, so I cannot do balance between positive and negative. Okay, the balance must be on the same side of the zero. Okay, so there you will one balance here, one balance line here, freehold line here, and the other freehold line on the other side. Okay, this is one portion of the graph, this is another portion of the graph. You cannot mix them. Okay, clear? What about the last portion? Can I have balance here? No, why not? Because E dash is around station 18 or something. My project finishes station 20. So there is no 500 feet. So all of it is what? Overhaul or freehold? All of it is overhaul. It is what? Up to 500 feet is what? Free. Okay, up to 500 feet is free. Okay, so this is part of freehold. Anything less than 500 feet is part of freehold. He will transfer without any extra payment. Yeah, he may charge you for extra material if he has to bring it, but he will not charge you for transfer. Got it? Clear? Okay. So later on we will look at the calculation for that.